Hello everyone, today we are going to start lecture 01 of class 8 mathematics chapter number 7, which is cubes and cube roots. In this lecture we are going to talk about what are cubes and what are properties of cubes. So let us start by defining what are cubes. Now we all know when we multiply a number by itself twice, then we get the square of that number. Similarly, if we multiply a number by itself thrice, that is 3 times, then we get the cube of that number. Okay, so we can very well define that the cube of a number is that number, cube of a number is that number raised to the power 3. Raised to the power 3. Thus, 2 cube would be what? 2 into 2 into 2, which is nothing but 8. Similarly, we can say that 3 cube is equals to what? 3 into 3 into 3, that is 27. Okay, so 2 cube is equals to 8, and we say, how do we read that? We say that cube of 2, cube means power 3, okay, square means power 2. So we say that cube of 2 is 8, right? Similarly, if you found out 3 cube would be what? 3 into 3 into 3, that is 27. And we say, here also the pattern is same. We say that cube of 3 is 27, right? And so on. Similarly, you can calculate cube of 4, which is nothing but 64. Similarly, cube of 5 can be 125. So basically what a cube means that when you multiply a number by itself thrice, then you get the cube of that number. Similarly, if you multiply any kind of number twice, you get the square. So in the same principles we can define this cube. So cube of a number is nothing but that number raised to the power 3. Okay, so let us now talk about what are perfect cubes. Obviously, you can multiply 1.1 into 1.1 into 1.1. That is, you can multiply 1.1 into 3 to itself thrice, then you will get 1.1 cube. So you can get cube of practically any number. Also, 0 cube is also 0 only. But to find out perfect cube, we all know that natural numbers are used, or I must say that cube of natural number are something called perfect cube. Obviously, if you find the cube of 1.1, it would be something, but it would not be a perfect cube because it would not be an integer. Okay, so basically cubes which are actually integers are called perfect cubes. Now obviously 27 is 3 cube and 2 cube is 8. So what are the numbers between 8 and 27? 9, 10, 11, 12. 12 is also an integer. But is it a perfect cube? No, because when you find a number whose cube is 12, it would not be a natural number. So we can define perfect cube as a natural number. Natural number is said to be a perfect cube if it is the cube of some natural number, right? So we have also studied them in the square section, that perfect square are what? Square of natural number. Similarly, perfect cubes are what? Cubes of natural number. Example, 1 cube equals to 1, 2 cube equals to 8. These are natural numbers, 1, 2. Similarly, 3 cube equals to 27. Similarly, 4 cube is equals to 64, and so on. Okay, you can go on and on and on. Similarly, if you find 8 cube, it would be 512. Similarly, you can calculate 9 cube, 10 cube, etc. Okay, so you can write etc. So, comma, it follows that, see, since we have perfect squares as 1, 4, 9, 16, 25, which are nothing but the squares of natural numbers. Similarly, it follows that each of the numbers, that each of the numbers, 1 because it is 1 cube, 8 which is 2 cube, then 27 3 cube, 64 it is 4 cube, 125 it is 5 cube, 216 it is cube of 6, 343 it is cube of 7, similarly 512 cube of 8, 729 cube of 9, and 1000 which is cube of 10. That it follows that each of these numbers is a perfect cube, right? So you can very well say that a number when multiplied by itself thrice will give a cube, but if that number turns out to be a natural number, then the cube which we are getting is nothing but a perfect cube, right? So how do we test that whether a cube is perfect or not? Okay, so we have some steps which we should follow. So we should talk about testing a perfect cube. Now similarly, in the case of squares, we have talked about testing a perfect square. So what we did was we did prime factorization of the numbers and then we started making pairs. Similarly, here also we will do the prime factorization and we will start making triplets of the same factors. Okay. If all the factors are triplets, then the number is a perfect cube. If something is left out of triplet, then the number is not a perfect cube. Okay. So let us write steps. Step 1 is obtain the natural number. Okay, so that is the first step, that you should obtain the natural number. Second step, express the given natural number as a product of prime factors. Okay, so we should express the given natural number as a product of prime factors. That is basically we are asking you to do the prime factorization. What is step number 3? Third step says, now this is an important step, as in the case of squares we did some pairs, here we have to form triplets. Okay, so it says that group the factors in triplets in such a way that all the three factors in each triplet are equal, right? So all the three factors in each triplet should be equal. So we have to group the factors in triplets, right? Now let us talk about the final step. Step number 4. Now it will decide on the basis of these triplets that whether a number is a perfect cube or not. So this step says that if no factor is left over in grouping, in step 3, then the number is a perfect cube, right? So if you get all triplets, then you can multiply the number by itself thrice and you will get this bigger number which we are actually factorizing. So if nothing is left over in the grouping in step 3, then the number is a perfect cube, comma, otherwise not. So if you find any number out of the triplet, then the given number is not a perfect cube. Okay, and if you want to find the natural number whose cube is given, then let us write that also. To find, basically what we are finding is cube roots. We are going to discuss cube roots separately, but you already know from squares that this particular thing, taking one factor out of pair, is was used to find square root. Here what we are writing, that to find the natural number, whose cube is the given number, comma, take one factor from each triplet, and multiply them. Okay, so if you take one factor from each factor and multiply them, then the number so obtained would be cube of the given number. Okay, so the number that would be obtained would be used to find the cube of the given number. Okay, so we can write the cube of the number, which you are getting by multiplying these. The cube of the number so obtained, whatever you will get after multiplying them, so obtained, if you cube that, then it will be the given number, right? So we have just found the number whose cube has been given to us. So this method works only when it is a perfect cube, right? So if you do not have perfect cube, then it would be very hard to calculate the cube because it would come in the decimals, and this method will not be suitable, because in the prime factorization method there will always be one factor or two factors out of the triplet. Okay, so you should remember that as in the case of squares, prime factorization work only for perfect square, so here also it will work only for perfect cube. Okay, let us solve a question to apply these steps and find the cube of the number. So we have to find the cube. We have to find that it is a perfect cube or not. Basically, okay. So let us find out that it is a perfect cube or not. So the first step says that you should obtain the number. Okay, we have obtained it. Then express the given number as a product of prime factors. So for that we have to do prime factorization. So we have to make this. So it is 27000. So we'll divide by 2. It will be 13500. Then again it is an even number, so we'll divide by 2. So it would be 6750. Again, since the unit digit is 0, it can be divided by 2. So we will get 3375. Okay. Then we will divide by 3 and we will get 1125. Again we'll divide by 3 and we will get 375. Okay, then again it can be divided by 3, so we'll get 1, 2 and 5. Obviously now we know that 25 is the cube of 5, so we'll divide by 5, we'll get 25. Then again 125 is the cube of 5, so we'll get 25. Then we'll divide 25 by 5 and then again 1. Okay, so now we have to write the second step. The second step said that express this in the form of factors. So 27000 is nothing but 2 into 2 into 2 into 3 into 3 into 3 into 5 into 5 into 5, right? Now the third step said that group the factors into triplets. So these are the triplets that have been formed. Now you can clearly see from step number 4 that no factor is left over in the grouping. So this number is indeed a perfect cube. Now if you want to find whose cube is that, so you can find out by taking one factor from them as common. So I can see that it would be 2, it would be 3, it would be 5. Okay, so 5 into 3, 15 into 2, that would be 30, right? So 27,000 is nothing but 30 cube, right? So in this way you can check that if a number is a perfect cube or not. I hope it was very easy to understand, right? Let us talk about another question. Now this question says, and what is the smallest number by which 392 must be multiplied so that the product is a perfect cube, right? So clearly, since this is asking, this question is asking to multiply it by something, that means that 392 itself is not a perfect cube. So let us see that which factor is missing and what we can multiply to this number. So let us divide by 2, so we'll get 196. Again, if we divide by 2, we'll get 98. Again, if we divide by 2, we will get 49. Now clearly there are 3 2's, so it is complete triplet. Now if we divide by 7, we'll get 7 and then again 7. So from the figure only we can see this prime factorization, then 1 7 is short from the triplet. So 392 is nothing but 2 into 2, which is making a perfect triplet, into 7 into 7. So there needs to be one more 7, or these two 7's have to be removed. But since the question is asking for multiplication, so we should add one more 7. That is, we should multiply the number by the 7. So we'll be adding this one more 7 to this triplet, right? So we'll write clearly 7 into 7 is not a triplet. So we are short of a 7. Clearly 7 into 7 is not a triplet. So we should multiply. So we should multiply 392 by 7 to make it a perfect cube. Obviously if you multiplied 7, then the triplet of 7 will be completed, and if you take 2 and 7 1 from these triplets, so you can very well find out that after multiplying by 7, the number which it will become will be actually cube of 14. Okay, because 7 into 2 is 14. So that was the question, that what is the smallest number to be multiplied by 392. Similarly, we have one more question which says, what is the smallest number by which 3087 must be divided so that the quotient is a perfect cube. So now it is asking for division so that the quotient is a perfect cube. So let us solve it. Let us first of all find that why 3087 is not a perfect perfect cube, and then we will be able to identify that what is the number which is needed here. So the sum of the digits is 11 plus 7, 18, so it is divided by 3. So we'll use 1, 0, 2, 9, and again 1 plus 9, 10 plus 2, 12. So again the sum of digits is 12, which is divisible by 3. So the number is also divisible by 3. That is the divisibility test of 3. So if we divide by 3, we will get 3, 4, 3, which is again 7 cube, because if we divide 3, 4, 3, we will find 49. And if we divide 49 by 7, we will find another 7. And if we divide 7 by 1, we will get 1 time, right? So the prime factorization has been completed. So if we write 3087 in the terms of factors, it would be 3 into 3 into 7 into 7 into 7. So you can very well see that these two 3's are extra, because 7 into 7 will be a perfect cube. So we have to, since we have to divide, we do not have to multiply, so we have to divide. So we should divide by 9 so that we can remove these two 3's from the number, and we'll get a perfect cube, which would be 343. Okay, clearly 3 into 3 has no triplet. It is left outside. Okay. So we must divide 3087. We must divide this number 3087 by 3 into 3 is equals to 9, comma, so that it will become a perfect cube, right? So to make it a perfect cube, we will divide by 9, and obviously you can see that after dividing by 9 it would become 343, which is again 7 cube. Okay, so in this way you can calculate the cubes and you can check whether a number is a perfect cube or not. Now let us talk about some properties of cubes of numbers, right? So properties of cubes. So there are certain properties which are to be known and which are very specific. So let us talk about the property number 1. Okay. So it states that cubes of all even. Okay, all even. Cubes of all even natural numbers. Cubes of all even natural numbers are even, right? That is, you can say 2 cube equals to 8, and if you see 6 cube is equals to 216. So they both were even numbers and their cubes are also even. So that happens, right? Because when you multiply one even number, even if you multiply only one even number with anything, it would become even, right? And since here you will multiply the same number 3 times, so it will obviously be a even number, right? Similar property holds for odd numbers also, where it says that cubes of all odd natural numbers, are odd. You can see the example as 3 cube is equals to 27. Similarly, if you take 9 cube, it will be 729. 5 cube would be 125. So they are all odd, right? Third property states that cubes of negative integers are negative. Because we have to multiply negative into negative into negative. So 2 negative would be positive, but when you multiply it for the third time, it will again be negative. Okay, so if you want to see examples, it is minus 1 cube is what? Minus 1 into minus 1 into minus 1. So this minus 1 would be plus 1 into minus 1 would be still minus 1. Similarly, if you take minus 2 cube, it would be minus 2 into minus 2 into minus 2, that is equals to minus 8, right? Similarly, you can write cube of 9, 8, 7. Similarly, you could calculate minus 5 cube. So minus 5 cube is also minus 5 into minus 5 into minus 5, which is equals to minus 125, right? So these were the 3 properties. Now let us talk about property number 4, right? So property number 4 states that for any rational number, a upon b, comma, we have a upon b whole cube equals to a cube upon b cube, right? So for any rational number that is a fractional number only, that a by b whole cube would be distributed to the numerator and denominator. Okay, so you can calculate the cube separately and then put the value in this formula. If you want to see an example, it would be like suppose 2 upon 3. Okay, so someday if I have to calculate 2 upon 3 cube, then it would be just 2 by 3 into 2 by 3 into 2 by 3. So you can see 2 upon 3, 2 upon 3, 2 upon 3. If you multiply them, you would get 8 upon 27. Right. So 2 by 3 cube is nothing but 8 upon 27. Using this formula, if you actually dissipate this particular power to the numerator and denominator separately, then you will find it would be 2 cube whole upon 3 cube. So it would be already be 8 upon 27. Okay. Now fifth property says, and similarly this property also holds for negative numbers. Let us talk about negative also before writing the next property. For example, if you calculate minus 2 upon 3 cube, so again you have what actually you are doing is minus 2 by 3 into minus 2 by 3 into minus 2 upon 3, which will eventually will be minus 8 upon 27. Right. So 2 by 3 cube is 8 upon 27 and minus 2 by 3 cube is minus 8 upon 27. So for any rational number, we can actually separate the powers on numerators and denominators. Now what the fifth property has to say, it says that the sum of the cubes of the first n natural numbers the sum of the cubes of the first n natural numbers is equal to the square of their sum. You can call it a pattern also. What it is actually saying, let me show you. It says the sum of the cubes of the first and natural number is equal to the square of their sum. Basically what it's saying, sum of cubes, that is 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube. Okay, so sum of the cubes of first natural numbers, yes, is equal to the square of their sum. Basically it says that square, that is 1 plus 2 plus 3 plus dot dot plus n. Okay, and then we have a square. So first of all we have to calculate this, then we have to do the square. So sum of the cubes of first and natural numbers is equal to the square of their sum. So this is the property. So sum of the cubes or square of the sum, they both are numerically equal. It is strange, but yes, it is true, they are equal. So let us talk about the last property, which is the property number 6. It says that, it is very important, it says that cubes, it said the cubes of the numbers ending, cubes of the number ending in the digits 1, 4, 5, 6 and 9 are the number ending in the same, cubes of the numbers ending in digits 1, 4, 5, 6 and 9 are the numbers ending in the same digit. Right. For example, if your number ends in 1, and you can very well imagine that square of 11 also ends at 1. If your number ends at 4, you can very well imagine that cube of 4 also ends at 4. If your number ends at 5, you can very well say that cube of 5 ends at 5. Okay, so cubes of the number ending in digits, these are the 5 digits, are the number ending in same digit. Right. Okay. So further this says that cubes of numbers ending in digit in digit 2 ends in 8. That is correct, because 2 cube equals to 8. So anything ending at 12, if you do cube of it, you will always get a number which ends at. Okay, so cubes of numbers ending in digit 2 ends in 8, and cube of numbers ending in digit ending in and cube of members ending in digit 8 ends in 2, right? So if a cube of a number ending in digit is 8, so if for a cube of numbers ending in digit 8 will end at 2, right? Suppose if you calculate the cube of 8, then it is what? 512. See, the cube of 8 itself is 512. So you can very well imagine that if you tomorrow calculate cube of 78, right? Because it should end at 8. If you calculate cube of 78, it would end at 2. It would be a very big number, but it would end at 2. Okay, so we have seen this particular analogy in squares also. Similarly, the cubes of the numbers ending in digits 3 and 7, and so cubes of number ending in digits 3 and 7. So you very well know that 3 cube is 27 and 7 cube is 343. The cubes of number ending in digits 3 and 7 ends in 7 and 3 respectively. Right, so cube of numbers ending in digits 3 and 7 ends in 7 and 3. So if your number ends at 3, suppose you are calculating cube of 43, you should know that your number would be anything but it would end at 7. So if your number is ending at 7, suppose you are calculating cube of 97, your cube will always end on 3. So these were the introduction of cubes and some properties. Now as we did in the square, you should always learn cubes of natural numbers till 1 to 20. Okay, I am not asking for more, but in every lecture we would remind this thing that you should learn the cubes of natural numbers from 1 to 20. Okay, because they will be directly used in the particular chapter. So that was all about this lecture. Thank you for watching this lecture till end. I hope that you all got great